Vaccination is a miracle of modern medicine. In the past 50 years, it saved more lives worldwide than any other medical product or procedure. However, the fascinating story of vaccination goes back all the way to ancient Greece. 429 BC, Thucydides notices that people who survive smallpox do not get reinfected. 900 AD, Chinese discover variolation. The Chinese were the first to discover and use a primitive form of vaccination called variolation. It was carried out as early as the 10th century, and particularly between the 14th and the 1700s. Variolation spreads around the world, as variolation eventually spread to Turkey and arrived in England in the early 18th century. While in 1796, Edward Jenner discovered vaccination. In 1803, a vaccine is a substance that is introduced into the body to prevent the disease produced by certain innovative techniques now drive vaccine research, with recombinant DNA technology and new delivery techniques leading scientists in new directions. Disease targeted have expanded, and some of the vaccines research is beginning to focus on non-infectious conditions such as addiction. A vaccine consists of dead pathogens or alive, but attenuated organisms. The vaccine induces immunity against the pathogen, either by production of antibodies or by activation of T lymphocytes. Scientists take many approaches to designing vaccine against a microbe. These choices are typically based on fundamental information about the microbe, such as how it infects cells and how the immune system responds to it, as well as practical considerations, such as regions of the world where the vaccine would be used. The following are some of the options that researchers might pursue. The types of vaccines are live attenuated vaccines, inactivated vaccines, subunit vaccines, toxoid vaccines, and DNA vaccines. DNA vaccines. Once the genes from a microbe have been analyzed, scientists could attempt to create a DNA vaccine against it. Still in the experimental stages, these vaccines show great promise, and several types are being tested in humans. DNA vaccines take immunization to a new technological level. Toxoid vaccines. For bacteria that secrete toxins or harmful chemicals, a toxoid vaccine might be the answer. These vaccines are used when a bacterial toxin is the main cause of illness. Scientists have found that they can inactivate toxins by treating them with formalin, a solution of formaldehyde and sterilized water. Such detoxified toxins, called toxoids, and are safe for use in the vaccine. The side effects of vaccination. Vaccination may cause dizziness or fainting after vaccination process as a side effect, but fever is considered the most common side effect that appear after vaccination, and also fatigue is one of the very common side effects. Redness, tenderness, or swelling at injection site and mild rash that may appear on the skin may appear for patients, especially when they are very sensitive, and also itching at the site of injection. Cough and nausea that appear on children after vaccination are considered mild side effects. Pain is considered the most common side effect, which appears after and during the vaccination process, especially with children. After vaccination, headaches could appear as a side effect for some people and make them suffer from tiredness for a long time. The route of administration is the path by which a vaccine is brought into contact with the body. Oral administration of vaccine makes immunization easier by eliminating the need for a needle and syringe. Intramuscular injection administers the vaccine into the muscle mass. Vaccines containing adjuvants should be injected intramuscularly to reduce adverse local effects, while subcutaneous injections administer the vaccine into the subcutaneous layer above the muscle and below the skin. The future of vaccination. First of all, vaccinomics. This is the concept of personalized vaccines that are tailored to an individual's body to maximize effectiveness and minimize any side effects. Then, cancer vaccines. Scientists are also exploring the possibility of vaccines that could teach our immune system to recognize and destroy cancer cells. Although therapeutic vaccines like this may still be a long ways off. Then vaccinating against HIV. The HIV virus's unusual structure protects it from being recognized and destroyed by our immune systems. But scientists around the world are working hard to create one to be used in the future.